What if your AI coding assistant didn't just answer questions? What if it came with a team of specialists built in? One who knows your commit conventions cold. One who handles security scans end-to-end. One who orchestrates full deployment pipelines on demand. Each expert knowing exactly when to step in, no prompting required. That's the Claude Code plugin ecosystem. And in this series, we build it from scratch. Here's the thing about Claude Code out of the box. It's genuinely powerful, but it's also completely generic. Every project means explaining your workflow from scratch, your commit conventions, your deployment process, your team's naming patterns. Claude follows along, but you're the one carrying all the context, every single time. And it's not just onboarding, it's the micro decisions that pile up. Should I run the linter first? What's our PR description format? Over time, you end up being the system's memory, the expert layer, which is exactly backwards. The plugin ecosystem is how you flip that. Let me show you what that looks like in practice. I've got 14 changed files across a project, infrastructure updates, API changes, config tweaks, new tests. Normally, I'd figure out how to group these into coherent commits myself. Instead, one command. The commit plugin kicks in immediately. A discovery agent spins up in the background, isolated read-only, just analyzing the diff. It groups the changes by semantic topic and hands back a structured commit plan. I review it. Looks right. I approve. An execution agent takes over, stages each group, and creates the commits, proper conventional messages, correct scope, nothing mixed together. 14 files, 4 coherent commits, about 30 seconds of interaction. That's a plugin doing what it's designed to do. So how does that actually work? What's happening under the hood that turns a single command into a multi-step coordinated workflow? That's what the rest of this video is about. The two building blocks behind every plugin, skills and agents. A plugin is an installable extension that gives Claude Code domain-specific knowledge and capabilities. Install the Kubernetes security plugin. Now Claude knows your cluster topology, your audit policies, your exact compliance rules, without you having to explain any of it. Install a video production plugin. Claude orchestrates a full pipeline from script to finished MP4 automatically. Under the hood, every plugin is a collection of skills and agents, coordinated by a single orchestrator. The plugin's entry point detects what you want and routes to the right component. But to understand why that architecture matters, and why it breaks when you get it wrong, you need to understand what skills and agents actually are. Skills are the simpler building block. A skill is a set of instructions injected into Claude's current conversation context when you invoke it, rules, workflow steps, domain knowledge, loaded into the same session, same context window, same model. Skills get an allowed tools list. Tools on that list skip permission prompts. It's not a restriction on what the skill can do, it's friction removal. And technically, skills can run with their own model tier or in an isolated Git worktree. But in our design, we keep them lean on purpose. Every token in the main context has a cost, and as that context grows, model performance degrades, what's called context rot. So when a task would pull in content the main conversation doesn't need to hold on to afterward, we offload it to an agent. The skill stays focused. The context stays healthy. Agents work differently. An agent is an isolated subprocess, its own context window, its own model tier, and a strict tool allow list. Not a permission shortcut like skills get, but a hard constraint. The agent can only call tools on that list, nothing else. It doesn't share state with the parent conversation at all. That isolation is the point. Give an agent read-only tools and it physically cannot write anything. Run it on a lighter model tier for tasks that don't need heavy reasoning, real cost savings at scale. Run multiple agents in parallel without their contexts touching each other. And when the agent finishes, the main conversation only gets the result. Everything the agent read or processed to get there stays in its context, not yours. Here's where our design proposal gets specific. One pattern we lean on heavily is the thin skill wrapper. The skill's job is to gather everything the agent needs before the agent starts, not to do the work itself. That might mean injection syntax. A script runs at skill load time, its output gets embedded directly into the skill content. No tool calls, no context overhead, the information is just there when the agent needs it. Or it might mean asking the user a couple of targeted questions up front. Either way, by the time the agent is spawned, it already has what it needs in its prompt. No exploration, no guesswork. The skill handles setup efficiently. The agent handles execution in isolation and returns only a summary. Those intermediate contents, the file reads, the search results, never touch the main context. Here's what breaks when you get this wrong. The problem isn't a skill spawning an agent, that's the pattern. The problem is treating a skill like an agent when isolation is what you need. Say you want to explore 3 folders in parallel, 3 agents, each runs isolated, returns a result. The main context gets 3 summaries. 3 skills doing the same thing inject the full skill body 3 times into the main context. The same instructions repeated while the main model does all the work anyway. No isolation and unnecessary bloat. The reverse matters too. Not every step benefits from an agent. If a task is fast, doesn't generate content the main context shouldn't carry, or costs more to spin up than it saves, do it in the skill. The goal isn't to route everything through agents. It's to put each primitive where it actually belongs. So how do we structure a plugin to hold all of this together? Here's our design proposal, and it's important to be clear. This is how we recommend building plugins, not something Claude Code enforces. Claude Code gives you skills and agents. How you organize them is up to you. In our approach, every plugin has one master skill, a single entry point whose only job is to detect intent and route to the right handler. Sub-skills manage workflows that stay in the conversation, set up steps, iterative decisions, anything where back and forth matters. Agents handle discrete bounded tasks that benefit from isolation. Claude sits at the center coordinating. Each component does one job, and because the separation is clean, you can add new capabilities without touching what already works. We'll go deeper on each of these patterns throughout the series. Let's be precise about what happened in the demo. When you typed, "commit this," Claude matched your intent to the commit skills description and loaded it. That's Claude Code behavior. The model reads skill descriptions and picks the best match. From there, the orchestrator made the next decision. Spawn a discovery agent with read-only tools to analyze the diff. Why an agent for that? Because analyzing 14 files means reading content that only matters for generating the commit plan. Once the plan exists, those file contents are done. The agent reads them, processes them, outputs the plan, and that content never lands in the main context. The orchestrator presents the plan you approve. A second agent handles the commits. 2 agents, each with exactly the permissions it needs. The main context only ever sees the output. Now here's what makes this interesting beyond any single workflow. Plugins compose. Kubernetes plugin, commit plugin, database plugin, all installed at once, no conflicts. Skill invocation is namespaced. Calling skill commit :commit and skill deploy :commit are different calls even if both plugins have a skill named commit. Same name, different namespace, no collision. Public plugin marketplaces already exist, and you can always build your own private registry. Write a plugin for your deployment pipeline, share it, and your team has it in minutes. Because the orchestrator pattern is consistent across every plugin, Claude knows how to invoke any of them the same way. Claude Code stops being a generic assistant and becomes a runtime for specialized AI workflows your team actually controls. So here's what this series actually builds toward: 12 videos. This one gives you the mental model, the why behind skills, agents, and the orchestrator pattern. Video 2 lays down the plugin structure itself, the folder layout, the entry point, how everything wires together. From there we go deeper. Skills in detail, agents and isolation, multi-agent coordination, model tiering for cost efficiency, persistent data between sessions. Then the end-to-end, testing your plugin, documenting it, making it installable by someone who has never seen your code base. By the end, you'll have built a production-quality plugin from scratch, and you'll have the mental model to build whatever you need after that. Subscribe if this is the kind of depth you want more of. Next video, the plugin structure, the bones everything else builds on. See you there.